Okay. I hope you scan the QR code, and um, my plan actually today continue the trigonometry a little bit more and move to the polar coordinates and parametric equations. Um, if we finish the trigonometry and polar parametric, we will have another quiz. If not next week, next 2 weeks. Depends. But I think tomorrow is your match, right? What time? What time? 10. Okay. Until 11, right? Okay. Yeah, that depends because in this classroom, I think not all of you are the IATP students, right? I think one, two non-IATP. Yeah, non-IATP, non-IATP, two students. So, what do you think? Should we have just 1 hour, like from 11:10 to 12:10, or just keep as usual but missing the other students? What do you think? Yeah, because I think because the chapters is actually what I'm planning. The chapters for polar and parametric is not really that, like, the content is less than the trigonometry, so it should be taking I think two classes is enough. Two classes is enough. Two or three, yeah, two or three. So it should be enough. So depends on you. What do you think? Yeah, leader. What do you think? What do you think? Both are fine. They are missing. Okay. Okay. So okay. So you agree? Huh? No. You want to skip the whole day? Yeah. You want to skip the whole day? Yeah. That's what I thought. Okay. Uh, that's fine. And maybe I will give you just exercise. Is that okay? If tomorrow we are skipping our classes, what do you think? It's up to you. It's up to you. You discuss. Okay. So I will give you some exercises. Uh, hmm? Yeah, yeah. Also, you have options like the whole classes, like no class at all, or just like 1 hour class. I think I need to ask the one who will play. Do you think is it possible if you just take like from the match and then take the 1 hour class, or very likely? Okay, okay. Yeah. I will give you like exercises. Please. Okay. Then tomorrow I will give you these exercises instead of the full classes. Is that okay? Is that okay. And you can also maybe prepare for, you have calculus, right? The other one. Okay. Okay, let me continue a little bit in trigonometry. So this is the last part that we we have done. So basically, the addition, you can remembering this, and if they are the same angle, then this will be your double angle. So this comes from the addition formula for trigonometry. Okay, and then from these additions, actually we can also do the same thing with the subtractions. Let me write in a new page. Okay, so let me write sine alpha plus beta. Yeah, let me go directly writing both. Okay, now we have these two sine alpha plus beta and sine alpha minus beta. Okay, let's add this two. So this will be sine alpha plus beta plus sine alpha minus beta is equal this cos alpha sine beta minus cos alpha sine beta is 0. Okay. So this will be canceling out. So you will have 2 sine alpha cos sine beta. Okay. And I will multiply by all by half. Okay. So I will switching the right side to the left side. So sine alpha cosine beta is half and you get this expression. This called product sum formula. This is just to show you that from the previous identity or previous formula, you can combine and make a new formula. Okay, so I think the best way to learn is from here, and you can change the signs and change the signs. It will be useful, okay? Especially when you are dealing with the trigonometry in advanced learning, like in higher level mathematics, like calculus, differentials, and others. Okay, that's the product sum formula. Another examples that I need to show you is it's called the trigonometric equations. Okay, for example, I'm just giving you the examples. Okay, let's try this, the simple one. So the trigonometric equations, you need to solve for the variables. In this case, this is theta. So solve for theta. Okay, it can be x, can be any variables, but the idea for all equations is to solve for each variables inside. So if you have 2 sine theta and minus 1 is equal 0, it should be easy to be solved. So 2 sine theta is 1, sine theta is half, right? So what is theta? So if sine theta is half, what is theta? Huh? 30, right? Let me write with radians, pi over 6. Yes, that's correct. If you're just answering pi over 6, it's not a complete answer, because you remember in the trigonometry, in the unit circle, we've learned that there are 4 quadrants, right? So we need to mention all quadrants that makes this angle or makes this half possible, okay, with certain angles. Okay, so we need to plus 2, okay, pi, and also there's other angle, right, in which the sign is also positive, right? Should be what? Pi minus pi over 6, right? It's the second quadrant. Okay, so uh, pi minus pi over 6 is 5, right? 5 over 6. Okay, and simply add plus 2, okay, pi. Okay, this type of questions usually it's just solving like regularly, or if they have restrictions for some the angle restricted on some certain value, then you just use that certain value. Okay? Because there is no mentioning about where the theta will be. So all possible answers you need to write. Okay? Which angle the theta will be. Okay. Okay. The second example. 5 negative 2 sine squared theta and sine cos theta. So solve for theta. So 5 minus 2 sine squared theta minus 7 cosine theta. So the idea is to solve for theta, which means in this case, okay, we are not directly getting the expressions. The simple expressions, we need to modify the equations first. We need to modify either sine squared, or maybe if you see any other forms. But I think the most obvious one is the sine squared that we need to rewrite. Okay? Because it's already cosine, you can relate sine squared to the cosine squared, right? We can go to the basic formula. So sine squared is 1 minus cosine squared. And if we substitute the sine squared here, all will be with cos, right? At least. But this having quadratic, it's just linear. So let's rewrite the expressions. So 5 so it will be 3 plus 2 cosine squared minus 7 cos theta. Okay, now it's become the variables is cos, right? If you feel maybe you need to simplify cosine, let cosine theta become, let's say a. Okay. So I will write 2a squared minus 7a plus 3. And we can factorize this, right? Or I'm giving you the how to factorize, okay? Usually my method is making this table, okay? And putting all the numbers that possible to be factors. So 2a maybe and a. If we multiply, we become 2a squared. And then the other will be 3 and 1, right? But if I just make this positive, then it should be positive. So we need to make this positive, but this negative. So negative, negative, I think. If we make this cross multiply, it's negative 2a, negative 3a. Oh, it's negative 5. Maybe let's switch the 3 and 1. We cross multiply, it's 6, negative 6. This negative 1, negative 1, negative 6, negative 7, right? So our factors is 2a and a minus 3. Okay. So 2 cos theta minus 1 is 0, and cos theta is 3. So let's solve this one first. So cos theta is half. And this part is impossible, right? So ignore this part and just solve this one. So this is impossible. This rendered no solution. And this part is theta will be, the first answer will be pi over 3 plus 2k pi. And the other one is, we can add pi. Yeah, we can add it to 270, or if you want to just minus, that's also fine. Just like this, minus pi over 3 plus 2k pi. Or become 5 over 3, that's also fine. Okay. These two the same, okay, the same meaning, okay, the same angle. Okay, I think that's just additional review. So basically, to solve the trigonometric equations, if you cannot see the direct answer or the direct expressions, then you need to rewrite the form based on the identity in trigonometry. and some you need to solve by the quadratic equations. Mostly, most of the case, this will be the cases. Okay. Okay. I think I will stop for the trigonometry, and we can move on to the polar coordinates. Okay. So, two example for trigonometry. I will add more examples for your exercise later. Okay. Okay. Let me start the polar coordinates. Have you learned before polar coordinates? Learned before? Uh, any one of you just learn now? Before you have learned? No, never. You've just heard the word. Okay, so no, you've heard before. Uh, okay, have you heard before? No. Okay. Okay. So polar coordinates basically. Um, Let me show you the idea based on the polar coordinates. So first, okay, let me draw the x and y axis. Okay. This is the regular coordinates. Okay. Sometimes we call the rectangular coordinates. So if we have, for example, like I have like just line equations, and maybe I have point P. My point P here is basically composed of x-axis and y, right? So the ordinate is x, y. Okay, this is just regular, very basic um, rectangular coordinates. Okay. Now for polar, we don't have x, y. What we have is, let's say this is B. Okay. I have angle theta. Okay. And I have, like, remember the unit circle? You will have a radius. Okay. If this point P circling around, then this is my radius. This is my angle here. And I will write the point at P based on the new expression, the radius and theta. I will write the radius and theta. Okay. So it's not based on x, y axis. So we are saying that we are moving the perspective from x, y to r and theta. Okay. Okay. So we call this the polar axis. Let me denote this as O. Then OP or R is the distance from O to P. And theta is the angle between OP and polar axis. Actually, this vertical line is actually you can ignore the vertical line. This is just to help you to see the polar axis. The polar axis is actually just this horizontal axis like this. Okay. Now, if we have the P is 1 and 3 pi over 4. So if we have this, means the 1 will be our radius, and the angle will be 3 over 4 pi. Okay. And how you draw is simply similar with your unit circle. You are drawing from the polar axis. This is polar axis. Let's just make the vertical line to help to make sure that this is our center. Okay. I just make the scale. Maybe this is 1, and then we are need to move our angle based on 3 pi over 4. Maybe around that. Because this is pi over 2 divided by 2, maybe around here. Pi over 4, pi over 2. So 3 over 4 is this. And this is r, or this is r equal 1, and this is p. Okay, that's how you are denote the polar coordinates. Polar coordinates in calculus will be on next semester. So you need to know the basics, and we will have the polar coordinates in the next semester. Okay, I believe if I gave you another points, you need to. I believe you have the ability to point out the p. Okay, because I think it should be not too complicated. Um, and then because we learn this is rectangular coordinate, this is polar. We need to know whether we can transform this both of this or not. Okay, so the next thing in polar is um, polar rectangular relationship or relations. Okay, let me just start with the rectangular. If I have triangle, like in the trigonometry, let's say this is P. This is O. Let's say this is X, this is Y, this is R, and this is theta. Okay. Let's say this is our axis, the rectangular coordinates. Okay, remember that from previous classes, we are using this expression, right? And also we are agree that this Pythagorean also correct. And maybe I'm adding the tangent is y over x. So to change rectangular to polar or polar to rectangular, we can use all of these relations. Okay? So this xy is the rectangular, and you will have the r and theta, in which the r theta is the polar. Okay, so you can switch the rectangular to polar or polar to rectangular just by using this simple formula. For example, okay, let me just give you an example to begin with. So example, if find rectangular coordinates from um, polar coordinates, let's say polar coordinates 4 to pi over 3. So let me give you example. So r, and this is theta. We can begin with the rectangular. The x will be r cos theta. So x will be 4 cos 2/3 pi, in which this is negative half, so it's negative 2. Okay. And y is r sine theta. So y will be 4 sine 2/3 pi. But sine is positive. It's the second quadrant. So the rectangular coordinates is negative 2, 2. Okay. Okay. This is we move from the very basic. And if you are given the rectangular 2 and 2 square root of 3, if you want to move to the polar, you can look for first the radius, x squared plus y squared. So x squared plus y squared is r squared. You get the r, and then you get how you get the angle. You can use y divided by x. You get the tangent, and you get the theta. Okay, got it? Okay. Okay, that's the first section, polar rectangular relations. And the other sections, we will have the polar equations. So let me write. I will give you just directly the example. X squared equal for y. Express in polar. So we are going to use the r cos theta. Y is r sine theta. And then start from the x squared equal 4y. And exchange x and y. So r squared cos squared theta for r sine theta. So r Yeah, R is for sine theta divided by cos squared theta, in which we will have for tangent theta secant. Okay, so this is the polar expressions. So the idea polar rectangular or rectangular polar, you need to be able to convert, okay, all x and y become r and theta. Okay? If you see still x or y left in the equation, it's not finished yet. You need to solve it and make all r and theta. And similarly, from the r theta, if you want to convert to rectangular, you need to remove all r and theta, become the x, y only. Okay. Okay. Let me give you another example. So if you have r 2 plus 2 cosine theta expressed in rectangular. Okay, can you convert this to rectangular? So removing r and theta, making it x, y, with all um, the formula needed already been given. So x is r cos theta, y is r sine theta. Can you convert this to x, y? Try this one, maybe around 2 or 3 minutes. And in polar equations, you will have several characteristics in the shape for the formula. So maybe later I will give you the basic how to make or how to determine which property or which shape the polar equation will be given. This 2 plus 2 cosine theta, the shape will be called, it's called the cardioid. It's like a heart, but so it's like, yeah, it's like that, the shape. And it's possible to draw. But I think it should be on the left side, like this, like a heart. It's called the cardioid. There are several forms. The easiest one is the circle, and then we have the cardioid. We have it's called the limason, and I think we have 4 or 5. I think 4. The other 5 is basically just the variations. We will have a petals like a flower. So we will have the polar equations looks like this. It's possible to have, and Uh, I will tell you how you find all these forms. And we also have the lemniscate. It's like this. All this formula will be using. You will be use all this polar in next semester, including how you are determining the form, the shape, the property from the polar equations. Okay. So, but first, let's just express in rectangular coordinates. Have you done? No? Have you done? Okay. First thing. Okay. First thing. It is r and 2 plus 2 cosine theta. If we need to make it become x or y, yes, not changing the cos, but we already have the cos. But how the cos change to x? If if this have r, it will be x, right? Let's multiply all by r. Okay, so let's multiply by r. So we get r squared 2r plus 2r cos theta. Okay, and then what happened? Mm-hmm. This r squared is x squared plus y squared, right? From the Pythagorean. So x squared plus y squared. I just work. Let me just solve this to r, and then what will happen now? Mm-hmm. Yeah, but I think we have square root, right? It's better we just square both sides, right? To remove this square root, okay? Yeah, but the idea is fine. But let's just square it. So we remove this square root. So let's square both sides. From where? You will have Rx. You mean from here or from here? From here? Um, yeah, possible, possible. Yeah, possible. But let me just make it x squared plus y squared minus 2x, and this will be 4r squared, in which this is 4x squared plus y squared. I think if we just stop here, it's already all rectangular because it's x, y, x, x, y. There's no r, no theta. We can just finish here. That's still fine. If you want, if you want to simplify, become y equal x or x equals something y, that's also fine. But if you just stop here, it's fine because there is no specific instructions from the question. It is just expressed in rectangular coordinates, and it's already rectangular coordinates. Okay. Um, Maybe some additional point. Actually, the polar, if you see here, it seems that it has the x, y, right? But actually, it's not. Okay. So to draw the polar coordinates, actually, you will have, um, if you remember, like there's a certain paper that have the square, right? Yeah. In polar, it will be, and it has a circle, so you can draw the circle easily. Okay. That's how you are. going to be able to draw the polar easily. So it will have the pattern, and you just need to follow the pattern. And usually each line, it will be usually pi over 6, 3. Okay, usually it's 30 degree usually, but there are some maybe more smaller. Then you can make a small angle from there. But this is actually how to graph the polar. Okay, so this line will maybe I will call it the polar world. Okay, so when we switch the xy to r theta, we are switching the world, the xy, and going to r theta. Okay. Okay. I think we can just finish until here. Um, I will give some exercise for you, and tomorrow there is no class. Okay. Yeah. 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 Yeah.